So when looking at half-life, the first thing you need to know is the definition. Now there are two possible definitions for half-life. So the first one is it's the time taken for the number of nuclei of the isotope to halve. Well, the second definition is it's still the time taken, but this time for the count rate to halve. Here we're trying to find out the activity of a radioactive sample after the following numbers of half-lives. So if we take this radioactive sample with an activity of 7,168, after one half-life it would have halved, which would leave us with 3,584. After a second half-life, it would halve again, 1,792. After another half-life, it's going to keep going, which will be 896. Oh, it'll be 3 half-lives. After its fourth half-life, it will be 448. 5 half-lives, 224, and so on and so on. So when we're trying to work out the half-life activity, after one half-life, we can see that there would be 3,584. After 6 half-lives, 112. 8 half-lives, 28. 4 half-lives, 448. 2 half-lives, 1,792. And finally, after 3 half-lives, 896. For this example here, we're trying to work out how many half-lives have passed. So we know that the radioactive count life starts at 464. And we know that after 2 hours, it's fallen to 29. So to find out how many half-lives, again, we just need to keep halving it. So after one half-life, it'll be 232. After 2 half-lives, 116. After 3 half-lives, 58. And after 4 half-lives, 29. So we can see that in that 2 hours, it was 1, 2, 3, 4 half-lives before it turned. In this question here, exactly the same process. So this time we know it started off at 15,360, and 12 hours later it's fallen to 240. So again, if we keep halving it, it's 7,680, 3,840, 1,920, 960, 480, and finally 240, which is what we're looking for. And we can see that's 1, 2, 3, 4, 5, 6 half-lives. In these examples here, we need to work out the actual time of the half-life. In this first example, we can see that it starts at 512 and it falls to 32 counts per minute in 4 hours. So after one half-life, we'd get 256. After our second half-life, 128, 64, and then finally 32. So we can see that this took 1, 2, 3, 4 half-lives to get down to 32. So we know that 4 half-lives equals 4 hours. If we want to get to 1 half-life, obviously we need to divide this time by 4. Dividing 4 by 4 gives us 1 hour. Again, it's the same process for the others. So 344 fall into 43. So after one half-life will be 172. After 2 half-lives will be 86. And then finally it'll be 43. So we can see this is 1, 2, 3 half-lives. So 3 half-lives equals 33 minutes. And for 1 half-life, will be 11 minutes as we divide both sides by 3. Again, having a look at this one, so it's 784, falling to 24.5, so that'll be 392 after 1 half-life, 196 after 2, 98 after 3, 49 after 4, and 24.5 after 5. So we know that 30 days equals 5 half-lives. To get to 1, we'll divide this side by 5. We'll do the same to this side, which gives us a half-life of 6 days. We're running out of space for this last one, so I'll squeeze it in over here. So we start off with 1032, we fall into 129. So after 1 half-life, it'll be at 516. After 2 half-lives, 258. After our 3rd half-life, 129. So we know that 3 half-lives equals 21 hours. So dividing this side by 3 to give us 1 gives us 7 hours for the half-life over here. Okay, so if you're confident that you know your definitions, then tick it off here. If you're confident that you can find the activity given the number of half-lives, like we have over here. If you're confident you can calculate how many half-lives have passed. And finally, if you know how to work out the half-life of an isotope, you can tick this box over here and see what you've done.